Hello and welcome to this session. Today we will discuss string manipulation instructions and assembly language programs of 8086. Now string. What do you mean by string? String is an array of bytes or words which are stored inside the memory. Byte is a 8 bits and word is a 16 bits. Now there are total 7 string instructions that are move byte or word string, load byte or word string, store byte or word string, compare byte or word string, scan byte or word string, and repeat string instruction until specified condition exists. We'll discuss the string instruction one by one. This instruction copies a byte or word from location in the data segment to the location in the extra segment. The offset of the source in the data segment must be in the SI register and the offset of the destination in the extra segment must be in the DI register. For multiple byte or multiple word moves, the number of elements to be moved is put in the CX register so that it can function as a counter. After a byte or word is moved, SI and DI automatically is adjusted to point to the next source element and the next destination element. If direction flag is 0, then SI and DI is incremented by 1 after a byte move and by 2 after a word move. If direction flag is 1, then SI and DI will be decremented by 1 after a byte move and by 2 after a word move. Move does not affect any flag. The next instruction is load string byte into AL or string word into the register AX. This instruction copies a byte from a string location pointed to by SI register into AL or a word from a string location pointed to by SI into register AX. If direction flag is 0, then SI is incremented by 1 for a byte string and SI is incremented by 2 for a word string to a point to the next element of the string. If direction flag is equal to 1, then SI register will be automatically decremented by 1 and SI register is automatically decremented by 2 in case of load SW to point to the previous element of the string. Load S does not affect any flag. The next instruction is store string of byte or store string of word. This instruction copies a byte from register AL or a word from register AX to a memory location in the extra segment pointed by the register DI. In effect, it replaces string element with a byte from AL or a word from register AX. After the copy, this DI destination index register is automatically incremented or decremented by 1 or by 2 in case of word to point to the next or previous element of the string. The next instruction is compare string of byte or compare the string of word. This instruction can be used to compare a byte or the word in one string with a byte or word in another string. SI is used to hold the offset of the byte or word in the source string, and DI is a register which is used to hold the offset of the byte or word in the destination string. Comparison is nothing but the subtraction. The auxiliary carry flag, parity flag, carry flag, zero flag and sign flag and overflow flag are affected by the comparison, but the two operands are not affected after the comparison. SI and DI register will automatically incremented or decremented to point to the next or previous element in the two strings. The next instruction is scan a string byte or a string word. This instruction compares a byte in a register AL or a word in register AX with a byte or a word in extra segment pointed to by the DI register. Therefore, the string to be scanned must be in this extra segment and the DI register, destination index register, must contain the offset of the byte or the word to be compared. The next instruction is REP, REPE, REPNE, REPNZ. REP is a prefix which is written before one of the string instruction. It will cause the CX register to be decremented and the string instruction to be repeated until the counter register, that is the register CX, is equal to 0. These are the examples. The first example is REP move SB, that is move the string of bytes until the counter register CX is equal to 0. That means it repeats the move SB instruction until CX is equal to 0. Similarly, second example is REPE compare string of byte. That is, it compares the string of byte until the end of string. Similarly, the next example is REPNE SCASW. That is, it scan a string of word until a word in the string matches the word in register AX or until all the string has been scanned. REPE stands for repeat if equal and REPNE stands for repeat if not equal. Now we'll see the program which is based on the string instruction, that is, write an assembly language program for microprocessor 8086 to exchange a 10 byte block of data between the extra memory segment and data memory segment. Now the data which is already stored in the data memory segment and extra memory segment, will write a code. So the first statement we have written, assume CS as a code, DS as a data and ES as a extra. So these are the data segment blocks and this is the extra segment block in which we have written or we have stored some elements into data memory segment and extra memory segment. Now we will write a code in a code memory segment. So first of all we will initialize the data memory segment and extra memory segment. So we'll write move AX comma data and move DS comma AX. So whatever the data data is nothing but the data segment address, that is the first memory location address which is copied into the register AX, and the data which is in the register AX is copied into the data segment register. That means we are going to initialize the data memory segment by using these two instructions. And the next two instructions we have written to initialize the extra memory segments. We will transfer the first memory location of extra memory segment into the register ES. Now we will transfer the offset in offset register of extra memory segment and data memory segment. That is the offset of the extra data memory segment into the SI and offset of the extra memory segment into the DI. So load effective address OP1 into register SI and similarly load effective address OP2 into the register DI. Now to initialize the counter for 10 bytes, we will write move CX, 0AH. Now for exchange the data, the next instruction is move AL, ES colon DI, move SB, move DS colon SI minus 1 AL. These three instructions are used for exchange. That means whatever the data present on the first memory location of extra memory segment is copied into the register EN, then move string of byte instruction. After that, whatever the present in register EN is transferred into the first memory location of data memory segment. The next instruction is loop up. This instruction, up is nothing but the label which is given with this instruction. These three instructions are executed until the counter register CX is equal to 0. The last instruction is INT3 to stop the program. Now to end the code memory segment, we will write code ends and end start. Thank you.